Alrighty, so we know that there are both divisions of the autonomic nervous system, and we know that they have to play nicely together. Okay, if the parasympathetic system was not active, the sympathetic system would overtake or take over, and that would cause pathology, that would throw off homeostasis. So there must be this delicate balance between both of these systems. So there's an increase in the parasympathetic activity that's coupled to decreases of sympathetic activity. And what that basically means is, let's say you're in a fight or flight scenario, you're being attacked or you're being chased, you need to increase your sympathetic response, but you also likewise need to tone down your parasympathetic response. And that's what we mean by comparative secrecy, or this dual innervation. Both systems need to be fluctuating accordingly to bring about homeostasis. So if you increase sympathetic, you need to tone down parasympathetic. Okay, it's only going to work against you if you're trying to digest food and, secretions and rest while you're trying to flee. Okay, that doesn't make sense. So toning down parasympathetic response goes hand in hand with toning up or exciting the sympathetic response, and vice versa. Okay, vice versa. So let's look at an example of the autonomic reflex. So this is a series of events that takes place, again, unconsciously, unknowing to you, that elicits your autonomic response depending on what scenario your body's in. So we start off with someone who's standing up. Now, when you stand up from a seated position, all the blood in your body, or most of it, pools to your lower limbs. Okay, that's a natural phenomenon. This happens every time without you knowing it. All of that blood pools to your limbs, and the vessels in other areas of your body, your aorta, your upper limb vessels, they register that as hypoxia. They register that as being starved or deprived of oxygen, simply because most of the blood is going to your lower limbs. And so there are receptors on these arteries, your systemic arteries, that will detect this signal of decreased blood pressure. Okay, now again, this is all happening unconscious, unknowing to you. Within seconds, there will be signals sent from the receptors in your systemic arteries. Because of that decrease in blood pressure, those signals will be sent on afferent fibers, right? We talked about the direction of afferent fibers to your central nervous system, to the integrating centers in your central nervous system, okay? And so remember, afferent fibers go from sensory receptors up to the nervous system. And so increasing the frequency, okay, this is tying in something else we talked about, right? The fact that in order to signal some type of event, the nervous system can only play around with the frequency of action potentials. It cannot increase the amplitude or the duration. And so by increasing the frequency of action potentials, the afferent fibers can send the signal to the integrating centers that blood pressure has decreased in the systemic arteries, okay? Now, these centers are usually in the medulla, sometimes in the pons, and these centers will control your heart rate, okay? So they will determine whether or not your parasympathetic system is more influential on your heart rate, or your sympathetic system is more influential on your heart rate. Basically, whether your heart rate is fast or slow, okay? And so two things happen based upon this signal. Two things happen on the efferent pathway. So the response that's being sent back out to your cardiac muscle is to increase sympathetic activity, which will increase heart rate, but also to decrease parasympathetic activity, which will decrease or inhibit or negate that parasympathetic influence on your heart rate. And what that does is it increases blood pressure, right? If you increase the stroke volume, increase the contractility force of the heart, you basically increase your blood pressure. Now, doing so turns off this first signal. So the first signal from those receptors on your vessels, where they thought they were being deprived of oxygen, can be corrected by increasing the blood pressure, okay? And can you see how all of this happens very quickly, very unconsciously or subconsciously, and we don't even know that this is happening in our body. Every time you stand, this autonomic reflex takes place, okay? Especially if you were standing or lying, especially if you were lying in a supine position for a long time. So when you wake up in the morning, sometimes you may feel lightheaded, you may feel dizzy, and that's this reflex sort of settling and taking place. Alrighty, any questions on that? Any questions on that? Any questions? Okay, so basically to summarize here, we have two divisions of the nervous system. Okay, you should know by this point what type of general functions are associated with each division. So we know the parasympathetic system is rest, digest, quiet, relaxed states. This increases our gastrointestinal activity. This increases our glandular secretions, accepting sweat glands. Okay, our other glands, liver, salivary glands, lacrimal glands, are controlled with the parasympathetic system. It also decreases heart rate, decreases blood pressure. And when we get to the cardiovascular system, we'll see exactly how that's brought about. Okay, it decreases the force with which the heart contracts. On the sympathetic side, this is the fight, flight, or freeze response, right? So it also makes you sort of stop in your tracks. This prepares you for emergency states. This is elicited during stress, as well as during exercise. This increases your heart rate, increases your blood pressure. This helps to mobilize energy stores. So again, if you're being chased or attacked, you want to be metabolizing your biomolecules to make energy, right? To make ATP to help in that event. It dilates pupils. This helps to bring in more light. Again, if you're being attacked or if you're being chased, you want to be very well aware of your surroundings. Dilating the pupils helps to bring that about. And then it decreases gastrointestinal function, but also urinary function as well, okay? So the bladder function is decreased by the sympathetic response, okay? So you should know general functions associated with each division and how those change. Now, although both divisions are different and sort of control different types of functions, again, I keep mentioning they must act together. They must sort of hold hands in the middle. At rest, the parasympathetic system, however, is slightly more dominant, okay? And that kind of makes sense. Although we talk about them meeting in the middle, we kind of want the parasympathetic system to be slightly more influential when we're resting, right? In our normal, everyday resting state. We don't necessarily want them to be equal, okay? We want to be slightly more in a relaxed state, in a digestive state, okay? And so at rest, we have both systems playing a role, but more importantly is the parasympathetic system. It's slightly more dominant when we're resting, okay? Let's talk about some of the integrating centers. So we mentioned that example where we had signals being sent on afferent fibers up to some of the integrating centers, and let's point out where these are. So there's the pons and the medulla, and they have different types of centers. So there's the cardiovascular centers that control heart rate, that control blood pressure. There are the respiratory centers that can either speed up or slow down our respiratory rate, how fast we're breathing, okay? Also, there's the hypothalamus, and this brings in our emotional response to stress. So for example, if you're nervous about a test, if you had a bad breakup, this can elicit the sympathetic response because of its close association with the hypothalamus, okay? So other emotional triggers that may not be physical, that may not be around you, you can be sitting in your seat, think about something that's tragic or emotional, and that can bring about a sympathetic response. Likewise, this is why we practice mindfulness and meditation. You can be, again, sitting in your seat and think about something calming, relaxing, and sort of ground yourself and bring about the parasympathetic response, okay? So you can use this knowledge to control whether your body's in a stressed state, whether the sympathetic influence is more dominant, or whether you're in a more relaxed state, right? Okay. Now, this is a nice summary table. This talks about the different organ systems, different tissues, their effect, right, in the parasympathetic system, and then their effect in the sympathetic system or the sympathetic response on these tissues. Okay, so it's a nice sort of general study table to clear out the boxes and try to fill this in on your own. Alrighty. And then likewise, this is the continuation of this table. Okay.